Hello and welcome to the webinar. Today's topic is the evolution from ELK to Elastic Security. Thanks so much for joining us on this webinar produced by Actual Tech Media. This event is made possible with our friends from Elastic. Before we get started, there's just a few things that you should know about the format of today's event. My name is David Davis of Actual Tech Media, and I'll be serving as the moderator. As always, we want these events to be educational, and we encourage your questions. We'll be doing a live Q&A session at the end of the event, but keep your questions coming throughout. We're going to have a great presentation and some really cool demos today. So I expect a lot of questions on how the demos work, if you can do this, if you can do that. We've even got a best question prize to help further encourage your questions. I'll talk about that more here in just a moment. But first, I want to encourage you to check out the handouts tab there in your audience console. That's where you can download additional information on today's topic. At the end of the webinar, I'll be announcing the winner of our Amazon $300 gift card prize. If you're watching this on demand, of course, that drawing has already occurred. The prize terms and conditions can be found there in the handouts tab. And then, as I mentioned, we also have our best question prize to help maybe shake some of those questions loose if you're not quite sure if you should ask. This is for anyone who asked a question and meets the Actual Tech Media prize terms and conditions. You'll be entered into this drawing for an Amazon $50 gift card. We'll be contacting the prize winner after the event. All right, and with that housekeeping information out of the way, I'm excited now to introduce today's two expert presenters. Welcome to Mateo Rebenskini, Global Security Specialist at Elastic, and Joe Murin, Solutions Architect for Cybersecurity, also at Elastic. Joe and Mateo, it's great to have you on. I'll first hand it off to you, Mateo. Take it away.
Thank you, David. My name is Mateo Rebenskini. I'm a Principal Solutions Architect at Elastic. Joining me today is Joe Murin. He's another Principal Solutions Architect, and we're looking forward to share with you the evolution from ELK to Elastic Security. I've been with Elastic for almost 5 years, so I actually witnessed this evolution, starting from the basic ELK stack that you all probably know very well, to a comprehensive solution that we call Elastic Security for the security analytics use case. So starting with what's the ELK stack, for those of you that may not be familiar with ELK. So ELK stack became popular as the use of different components of different products that work very well together for different use cases, going from logging to metrics to security. The core is Elasticsearch. That's an horizontally scalable, very fast search engine. Kibana is the user interface. And Bits and Logstash are two components that are being used for a long period of time to simplify the ingest of data into Elastic. ELK stands for Elasticsearch Logstash Kibana. It's an acronym. When we introduced Bits, some community members, they started using that BELK that you can see there. That is kind of funny in a way. So how have things evolved from ELK to Elastic Security? So first of all, both ELK and Elastic Security, they're backed by Elastic as the same company, and it's actually the same product. Elastic has been investing in the last several years into building solutions for the most common use cases of ELK. The whole idea behind that is to provide easy-to-use solutions to your problems without having to build your own solution. For example, for the security use case, if you were using ELK, let's say 5-6 years ago, you likely had to build your data integrations to ingest data. You likely had to build your dashboards that you will use for threat hunting and so on. So it was certainly possible. Many of our customers actually did in the early days of ELK. Yet it's time consuming, right? And you can only do it if you have time and resources to do that. So let me talk a little bit about the differences between Elastic Security and ELK. And I will start by saying that there is the same product. So it's not a separate installer. It's still Kibana. It's still Elastic. Think of Elastic Security as an application running on the top of ELK, specifically running inside Kibana. You still retain the fast queries and the scalability that Elastic Security provides. You still have the capability of creating dashboards, visualizations. Still open and free, many of the features in ELK. and Elastic Security are free, and we retain that with Elastic with the security application. And both of them were created and supported by Elastic. What Elastic Security provides on the top of ELK is a lot of out-of-the-box integrations, detections, content in general, and also workflows that were designed for the analysts. We even have XDR capabilities that includes both endpoint protection and EDR. And more recently, we introduced cloud security capabilities that we announced a few months ago. These slides depicts the evolution, the Elastic journey from when Elastic Security was first introduced, thanks to the acquisition of a company called Endgame, to today with the recent release of cloud security. As you can see, we moved pretty quickly. The first SIEM release, that was the original name of Elastic Security, came out in mid-2020. So in a little bit over 2 years, we went to not having a solution for the security use case to having a full solution that not only includes SIEM capabilities, but also endpoint and cloud security. I'm now going to pass it to Joe that will take you through a short series of demos that are designed to highlight some of the solutions to common challenges that Elastic Security provides. Going to, for example, capturing all your data. How can you do it with Elastic Security? How can you leverage automation to free up the time and to spend less time chasing fake fires? How does the analyst experience looks like? How can you stop attacks at the source with endpoint security? And lastly, how to take security to new heights thanks to the cloud security capabilities. Joe, take it from here.
Thank you, Mateo. Yes, awesome introduction really to that evolution of ELK to Elastic Security that we're talking about today. And exactly, I have 5 small demos that I queued up for you, which we believe will highlight different challenges that all security operations center deal with, and really how Elastic Security, that purpose-built solution, can positively affect that. And the first one is capture it all. And what do we mean by capture it all? We're talking about really what everyone wants. Everyone wants to gain greater visibility into that ever expanding attack surface, meaning they want to add more data sources, and they probably want to keep that data longer. And we know that can be challenging. First off, is it even easy to ingest the data in the first place? And once you ingest the data, can you store that data cost effectively for whatever your retention periods require? So in this next short demo, we'll see how Elastic makes it easy to ingest common log source types, as well as how the platform keeps you in control of the cost of that deployment. So I'm going to jump out of slides here. I'm going to do this over and over again during this demo, but I'm going to jump out of slides. And let's take a look at Elastic Security. So first and foremost, I'm looking at a web page here. This is that Cabana that you heard Mateo talking about. And I'm specifically located under the security solution, that purpose-built solution. I'm just looking at an overview dashboard. And the first place I want to drive to, again, in the theme of ingesting or capturing all your data, is something called integrations. So Elastic provides tons of integrations for common log sources out of the box that Elastic builds and Elastic maintains. And this is a key differentiator for some of that ELK experience you might have had where you were talking about beats and Logstash. Furthermore, all of our integrations and the ingest architecture is a centrally managed component. So what do I mean by that? The next place I have to go from integrations is down to something we call Elastic Fleet. And again, this is the new ingest architecture. Not to say beats and Logstash are gone, they're still very much there, but these are what we call Elastic Agent. And you're seeing a list of agents that have enrolled into the Elastic platform and all belong to their own agent policy. So if I click over to agent policies, I'll see I have some Linux and Windows oriented policy. I have a cloud oriented policy, but the takeaway is that one agent belongs to one agent policy. And if I click on maybe, for example, the Windows prevent policy, I'll see that the policy can have one or more of those integrations we were looking at here. So this is just a standard Windows workstation policy with what I have at least 5 integrations applied. I'm getting some Windows and OS specific telemetry. I have some security oriented integrations here, Elastic Defend, which we'll talk about here later. We have OS Query, and we even have things like NetFlow and stuff coming off the wire, right? So we have a number of integrations associated with my Windows Prevent policy, which can have one or more agents assigned to it, right? So what if I had to quickly start ingesting some new data? Well, I could add an integration with this button here, and there's a few different ways to drive to the add integration page, but I'm back to my integrations, and maybe I need to get GCP, for example. Maybe I need to get Okta authentication streams. Maybe I need to get, we'll do Cisco. Somebody says, go out and get my Cisco Meraki telemetry. Well, I can do that pretty easily. I go to my integrations page, I select Cisco Meraki. I can see that not just am I installing an integration, but I have some out of the box, what we call assets, some dashboards that are going to at least help me visualize my data as it starts flowing into the system. And I don't have to worry about, ingest pipelines and parsing the data. Again, some of the stuff you used to have to always build on your own with Elk is being handled for you automatically. And I can just add that Cisco Meraki integration, give it a name, configure how maybe I want, in this case, this syslog listener to listen for the logs coming from Cisco. But ultimately down here at the bottom, I have a couple options. I can assign this integration to an existing policy, or I could even create a policy on the fly. In this case, though, I'm going to assign it to my Linux plus threat intel policy. And, there's a lot happening there. This box is kind of a purpose-built collector box. It does a lot of different threat feeds for me. So I'm going to put my Cisco telemetry there, and I'll hit save and continue, save and deploy those changes. And that should pivot me back over to the actual Linux plus threat intel policy, where I can see I have tons of integrations. So I came here purposefully so you can now see a couple Cisco Merakis here at the top, but also really emphasizing the point that one agent policy can have a number of integrations depending on what you need that collector agent to be doing for you. So that's all about getting the data into the platform, but and centrally managing those agents, right? Controlling things like agent upgrades and deployments. And again, also adding those integrations or removing integrations, removing agents between policies. Whatever you need to do, you're doing it centrally via that Elastic Fleet. But what about getting the data into the platform and storing it cost effectively? Well, all of your data can be assigned what we call an index lifecycle management policy. And all that really does is move data across data tiers. And every vendor has data tiers, and I won't get into the specifics here, but we're going to allow you to move your data from hot, which is your most performant, but also your most expensive tier, to warm, to cold, and ultimately to frozen. And frozen is what I want to focus on here, is because frozen is a data tier where we have separated the compute from the storage requirements of that tier, meaning the data is actually stored in an object store. In this case, it's stored in an S3 bucket. The data isn't indexed in its entirety inside Elastic all the time. So there is a performance hit on queries. Hot's going to be maybe milliseconds to seconds. Frozen's going to be minutes. So despite the name, minutes isn't too bad. And because all my data in the frozen tier is still accessible from Elastic Security, from that Kibana, from Discover, some of the tools you're already familiar with maybe, because all that data is still accessible and actionable, a few minutes for a search query beats the heck out of rehydrating a ton of data when you need to look back 6 months, 12 months, 5 years, whatever your retention periods are. So let me switch back to the slides. What did we see here with Capture It All? We saw Elastic making it easy to ingest data from a centrally managed architecture for a number of common log sources based on integrations that Elastic maintains. We also saw how the platform can keep you in control of your costs via those searchable snapshots in that frozen tier. And really, we're doing that without breaking the budget, right? Easy to ingest and budget-friendly retention. So moving on, another common, not problem, but challenge that operations centers have are analysts. Most SOC teams are overwhelmed and understaffed, and analyst onboarding time takes a long time. And what we need to do is make an analyst as effective inside the SIEM as quickly as possible. We need analysts spending their time on things that matter, right? We need to let the machine do all that repetitive work as far as floating to the top those known adversarial behaviors or those unknown, maybe machine learning derived anomalies. So during this demo, we'll see Elasticsecure's new detection engine, which is constantly chewing on your data and which comes with hundreds of out-of-the-box detection rules, out-of-the-box high-fidelity MITRE-aligned detection rules, float some of these most relevant indicators to the top and help an analyst figure out where they might want to start their day. So let's move back into Elastic. And the first place I want to go are under the security app. I want to drive to alerts. And from there, I'm going to drive straight into manage rules, right? Because right now I'm looking at a number of alerts that have flowed into the system, but I want to go manage the rules that are associated with this detection engine. And one of the first things I might notice is that, hey, I can update my rules that Elastic is creating for me, separate from maybe having to update the whole Elastic stack or to update the agent, right? I can update my rules with a single click here if there's new logic or new rules I want to apply to the detection engine. I also have rules for all different types of data sources, AWS rules, Azure rules. Maybe I want to zoom in on some execution rules, for example. And I'm just going to sort by the rule name so it's alphabetical. But let's take this first one, abnormal process ID and lock file created. If I click on that rule, there's a lot more to a rule than just this rule logic over here on the right. And as intimidating as that rule logic is, notice I haven't required my analyst to write a single line of code or anything like that. This is logic that our threat researchers are building for you. But more about that rule is included here in the rule definition. I'm also getting maybe reference URLs for context. If this rule fires, all this information comes over with that signal, with that alert, right? So an analyst can see this rule fired and immediately begin to read more about why that rule is significant, what false positives look like, and maybe one of the most desirable enrichments is some MITRE attack, MITRE tactic and technique enrichment where it makes sense for the different rule. So again, when the rule fires, it's not just that this logic was satisfied, but it's all this other context that comes over that helps an analyst triage. I wanted to note too that all rules can be actionable. So, you know, that rule fires and I get an alert in the SIEM interface, but maybe I also wanted to send an email or a Slack message or enter a new ticket in Jira or anything API, right? Via a webhook call. I want to orchestrate something, any API. Any of those hundreds of out-of-the-box rules can be actionable as well. Similarly, I actually want to pivot over to machine learning. So where we saw the detection engine continually chewing on your data based on hundreds of rules that describe adversary behaviors, or what we might refer to as the known, we still want to relearn on some of our time series anomaly detection that's baked into the platform to surface those unknown anomalies. So if I was to maybe create a new job here, and you know, Elastic says, what data do you want me to chew on? And this is kind of an Elastic thing, but I'm just going to pass it a very high level logs asterisk, logs everything data view. It's going to quickly look at that data and say, hey, based on your data, there's a lot of pre-configured jobs that we can create. Maybe we want to surface anomalies around Linux telemetry or network telemetry, or maybe authentication telemetry. So I click on, say, authentication, for example. I see I get 6 or 7 jobs that are geared towards, again, surfacing those anomalies. Maybe it's high counts of logon failures. Maybe it's a rare country or a rare source IP address by user who's signing into the platform, etc. But these anomalies can then be operationalized inside the SIEM. And we're not creating these jobs from scratch. We're allowing Elasticsearch researcher team to do it for us. Again, getting an analyst up and running quickly and allowing the machine to continually chew on the data. And lastly, when you're in the security app UI, I'm going to go to some dashboards and I want to check out this entity analytics dashboard. So given all those individual alerts that might have fired from the detection engine or anomalies from machine learning that might exceed some scoring threshold that I'm not comfortable with, the platform will distill all that information and begin to score and categorize different host-based, host and user-based risk scores, essentially, which again is a great way for a user to kind of start their day and to prioritize what they need to click on next. So clicking back on the slides, really what we saw here was how the elastic detection engine and that machine learning technology can easily surface known and unknown threats without the user having to write a line of code, right? Which you might be familiar with things like Watcher and stuff like that from the ELK days, which was very programmatically driven. Obviously, we're moving away from that. With hundreds of high fidelity out of the box detection rules, with all that MITRE attack context that's part of any alert firing, maintained and built by our threat research team, Elasticsearch Labs. And really the goal here is freeing up the analyst time so that they can focus on things that matter. Powerful detections without writing code. Moving on, another challenge is just having an intuitive user interface for the analysts to actually perform their core activity, which is to triage and investigate potential threats. Either responding to different alerts that have fired, or maybe triaging their own threat hunting output. But Elasticsearch introduces a number of UI elements inside the security solution that you didn't have in ELK, such as that entity analytics dashboard, to really help an analyst prioritize accordingly. So during this demo, you'll see how Elasticsearch really empowers any analyst to easily detect, investigate, and respond. So jumping back into Elastic, we were already on the entity analytics dashboard, which again is a great place for me to start my day with high criticality of hosts and users. Maybe I want to click a root user and drill into that user. But instead, let's stay in the security UI and let's go look specifically at some alerts. And I see that I have a number of alerts. Well, number one, I have some trending happening here across the top here. I can filter in or filter out different alerts if I want to maybe hide some noise or something like that. But I can see alerts that in this case have flown in over the last 24 hours. As I look down to my table rows for the individual alerts, I'm also seeing this event summary column, which is kind of like mind explosion, right? If you're used to Discover, where you had to continually bang out KQL or Lucene queries and you had to continually pin different key value pairs to create columns and a table view as part of your triage, you don't have to do any of that in the security UI. We have these event summary, these event renders, where we are trying to tell you quickly that, hey, a process, cat, from parent process sudo by user root on this machine. We're trying to build context and tell a little bit of the story without you even having to drill in or click on anything yet. And obviously, this process-oriented telemetry is going to look different than maybe network-oriented telemetry. We also have a couple of cool other UI elements here. If I hit this little diamond icon on this alert, I'll get a graphical representation of what that whole process tree looked like. And it's interactive. I can kind of click on the cat. I can see my cat Etsy shadow down here, which is a rule that fired. I can click on the alert associated with that and have a hyperlink over to the specific rule that fired if I want a graphical, again, representation of that kill chain or that process tree. Similarly, I can click on this little terminal looking icon, open in session view, to get admittedly a lot of the same information, but displayed completely differently, where I have more of a top-down chronology of everything that happened on this server, including when we opened initial terminal, we ran some commands that might not have jumped out at us during that graphical view, and when the initial alert fired. And one thing that's kind of cool here too is if I need to get, like, say, a full replay of everything that happened on that terminal, I can do that, right? And again, this really puts context into why did this alert fire and what was happening on the platform at the time. And now from here, I might take for the session view and expand this alert and talk a little bit about this screen, but I'm actually going to exit here and I'm going to exit out of the session view and I'm going to expand that same alert right from the original alerts table. So I've expanded out the alert. We see that alert context. We see some highlighted fields which float to the top, maybe some relevant aggregations that I can click on and interact with, such as this machine being a part of 57 other alerts. But now I want to take an action, and not necessarily a response action, but let's investigate in Timeline. And Timeline is a purpose-built user element, UI element inside the Elastic Security solution where an investigator will spend a lot of time, maybe pun intended, I don't know. But what I'm doing here is I clicked on a specific alert. So it's just saying, hey, alert ID, tell me more about that. But maybe I want to use some classic Elastic filtering technology. So I can hover over this element. In this case, it's a host name, and hit the plus button. And I'll see a little and relationship, this host name. So I want to zoom in on just this host. And maybe I want to, similarly, let's see any other cat commands that might have happened. And lastly, let's also grab like this user. And let's grab this user element and drag it up to this with a Boolean relationship here. So I'm saying, hey, if it's that specific ID that I clicked on or anything else that root did on this host with a cat process argument, right? So without writing a line of code, just doing some drag and dropping and some clicking, I've actually created a pretty specific query. And I can see that original shadow stuff here. And in timeline, I might want to start thumbtacking some of these most relevant alerts or events that have come in. And, I'll cheat a little bit, but if I scroll to the bottom, I might see some other catting that went on here where I'm seeing a password file was catted, right? And I might want to also thumbtack that. I can create a comment. Again, analysts work, analysts work product, right? And I can add that notes, but maybe it's links to OS queries, maybe it's links to other timelines that are hyperlinks, maybe it's screenshots, whatever it is. But I'm building out my work product here as part of this investigation as to why that original shadow alert fired. And maybe I want to give it a name. We'll just call it possible discovery, if I can spell it, and we'll save that. And the reason I'm saving this timeline is because if I am running down a rabbit hole that proves fruitful, I want to save my work product and probably attach it to either a new case or an existing case over here. And if I click new case, this is where I can, again, give it a name. I can assign it to different analysts on my team. I can give it some tags, a severity. I have a link to the timeline. I can add more context in the description. And also I can begin to orchestrate externally. So just like rules are actionable, my cases are also orchestratable. I can send this off to IBM Resilient or the swim lane SOAR or a Jira ticketing system, or really, again, anything webhook, right? So going back to the slides, what did we see here? We saw Elastic really making it easy and fast and intuitive with a number of purpose-built user interfaces, such as that entity risk dashboard that we saw, such as alerts that are enriched with that MITRE attack context. We also saw investigations, again, being fast and intuitive via a lot of those purpose-built UIs that you would not have seen before, like the event analyzer, which was the graphical process tree, the session view, the session replay that we saw. And ultimately, what we're doing is, just like the bullet point before, we're making this intuitive for the analysts and making it easy for the analysts and hopefully allowing them to do their most critical work faster and more effectively. Fast, intuitive workflows for security analysts. Moving on, let's stop attacks at the source. And, Mateo already mentioned endpoint, and that's what we're talking about. We're talking about that ginormous attack surface of all those workstations and servers in your environment, a key part of your attack surface that you need to gain visibility in, and that you need to have the same level of visibility and protections that really you have for everything else. And this demo will show us how Elasticsearch can really help minimize our risks on the endpoint and stop threats before there's a broader breakout. So let's take a look at Elastic again. And the first place I want to drive to are those integrations I was talking about before. Maybe education through reiteration, we can say. But if I type in something like Elastic here, just to see Elastic-oriented integrations, I see this Elastic Defend. And if I click on Elastic Defend, this is our endpoint product. This is that kernel level hard to bypass, high fidelity telemetry coming off the endpoint. This is not just Windows logs that can easily be cleared. These are tamper-proof kernel drivers, system extensions, K-probes, eBPF, depending on that Windows, Mac, or Linux operating system. So as I can see, the endpoint integration is living alongside a number of my other integrations, but what does that actually mean? Let's click in on this actual endpoint policy and see what it is that we're protecting on the endpoint, that we are preventing fully autonomously, disconnected from the Elastic mothership. Even if you didn't buy hotel internet that night, this stuff will work with no loss of efficacy. And I'm preventing malware here on the disk. This is also machine learning. It's a redistributable gradient boosted decision tree. So this is different than that time series anomaly machine learning that we saw inside Elastic. And also using things like YARA signatures, especially for Linux here. And notice all my protections can be in a passive detect versus more proactive prevent posture. I'm preventing ransomware breakouts, doing some unique things here too, including things like peppering the file system with canary files. If one of those files is touched, something's up. I have memory threat prevention. So sometimes when a binary is executed, it looks different in memory than it does on disk. So we're applying that those same math models, those same YARA signatures across Windows, Mac, and Linux. And I also have what we call malicious behaviors. And this one's unique in that by definition, if I'm observing a behavior on the endpoint, something happened, right? It already happened. It's not a pre-write, pre-execute kernel level. It's an I've observed something in the telemetry that is suspicious. And again, I can choose to detect or prevent it, try to kill that process. I do have some other, attack surface hardening where I can say wrap myself around a few processes like LSAS and Windows and monitor for things like memory dumps and pass the hash techniques. I'm sucking down these different telemetry streams from these different operating systems. Again, this is not Windows logs. This is right off of the kernel, hard to bypass, high fidelity telemetry. So that's a lot of words, and it's just a policy page. So what does that actually mean? If I was to look at Windows, for example, I have a piece of malware here on the desktop, and let's just extract that. And I should get a little binary here on the desktop, and it was so fast, it was quarantined so fast. I did get a Elastic Security pop-up here. I can choose to turn that off if I want to be super covert, but it was so fast that it was on the desktop for a split second and suddenly quarantined, right? Similarly, I have some samples on Linux here. And if I was to just unzip these samples, I'll see that I'm unzipping two files here, right, into the samples folder. And if I open that folder, so I'm going to notice that there's actually only one file there, .packed, right? And that's because ELF was not packed. So it was killed and quarantined just like the malware we saw in Windows. But packed survived because it's obfuscated on the file system, right? We can't read into it just yet. But if I was to do something like run that, the process will launch and hopefully quickly be killed. So we see that process was killed. That's part of the automated response functionality. And what does that actually look like inside the security product, inside Elastic Security? So let's just move from our cases UI, which we're done with, back over to alerts. And let's just look at maybe the last 15 minutes of telemetry. And I can see that I have some malware that was prevented. I also have a memory threat prevention that kicked off. I have those same event renders that we were talking about earlier. But now I want to take some really actions on the endpoint. And what might that be? Instead of just opening it up in a timeline, maybe I quickly want to isolate that host, right? And so that I can stop the bleeding, stop the data exfiltration, stop the lateral movement, right? But I want to isolate that host. And that is kernel level isolation across Windows, Linux, and Mac. This isn't like a firewall rule or something like that. But I can see that the machine has now been isolated. It's healthy and it's currently isolating. Give it another few seconds, that should change. And now I kind of can breathe a little bit easier and take the time to maybe do some further response and further investigation. So what might I want to do? Let's run OS query and just take the opportunity to ask some questions about the machine that triggered the alert. And in this case, we'll just take advantage of some of the out-of-the-box queries that we supply. In this case, we're going to look for listening ports. We're going to submit this, and shortly after, we'll start getting a table view of results back where I can add this information to timeline. I can view it in something called Elastic Lens. For analysis, I can attach it to a case, etc. So if these ad hoc queries become part of my work product, part of my investigation, that's a valid response, and I can save that material. And lastly, I want to show respond, or what we call a responder. And this is where we are emulating more of a terminal interface to those endpoints. And I can see some basic commands here where we saw that automated kill process kicking off before, but I can do analyst initiated kill processes. I can suspend a thread, I can dump processes, but this is where you will see more and more of those response functions, specifically those analyst initiated response functions that you might be kicking off here depending on how your investigation goes. So what did we see here? Expanding our slides. And what is it that we saw in this demo? Well, we saw most significantly that XDR functionality, that detection and response on our endpoint being satisfied from that same Elastic platform, that Elastic security solution, via that same Elastic agent ingest architecture that just has one more integration applied to it called Elastic Defend. We also saw data being quarantined automatically, processes being killed automatically. We saw that we can have analyst-initiated process kills and things like that as well. And it is a differentiator for us in the space. I won't talk too much about pricing, but unlike every other endpoint solution you might be looking at, we're not dollars per endpoint. This is just a new data source. Endpoint is just a new data source that's flowing into your Elastic stack, and you're going to be charged based on essentially resources, storage, and how long you choose the storage. And remember, you can use things like ILM to really balance and have a cost-effective deployment. Stop the bleeding before it even starts. And last but not least, let's talk a little bit more about taking security to new heights. So we're talking about cloud here, right? And as cloud and really SaaS have become the de facto standard of consuming online services, organizations, again, need to retain that same level of visibility and protections that they might now have on their endpoints that they have for every other data source. And when you start talking about cloud and SaaS applications, we're talking about containers, which is a new massive section of your attack surface that you need to have that visibility and protective posture in. And we're going to see how Elastic, so during this demo, we're going to see how Elastic allows you to gain visibility into your cloud workflows. We're going to see automated detections and identify some potential threats, as well as we're going to ensure that our cloud security posture is optimal. So what do I mean by that? Let's again jump into Elastic. And let's move over to one last time integrations. And actually, let's go to Fleet. Let's look at the existing agent policies that we have, and we'll see that we have a policy for workload protection and CSPM. Really, I want to say KSPM here because we are heavily focused on Kubernetes at this point, so KSPM is a more accurate description. But we have a few different integrations here that are running essentially sidecard to those actual Kubernetes nodes out there. Again, Elastic Defend, which is getting us that high fidelity telemetry off of those containers. And this is true for anything Linux, but absolutely containers. This is all accomplished via eBPF, not kbrobes, as long as your kernel is recent enough, which most containers are. But eBPF is a super least impactful way of interrogating those containers and getting that telemetry. We also have a couple Kubernetes specific integrations here, one that's going to allow us to evaluate our posture management, and one that's focused on a lot of the session views, a lot of those connections that containers are dealing with. So where does that data start to flow up? Let's go again back to the security solution. I'm going to go to just overview dashboards, and I click on, say, the Kubernetes dashboard. I'll see here that I have my actual Kubernetes architecture is displayed here, both logically, where I can see the actual nodes and the namespaces that are applicable. I can see a lot of the same UI elements that I had from the alert view that event analyzer, the session view. I can also do some things like, let's filter in just for interactive users. Let's expand out a little bit further. But I have, one interactive user that logged into a container, as opposed to the non-interactive users, a lot of the heartbeat mechanisms that maybe in this case GKE is doing in the background. And again, a lot of different opportunities, but those same UI elements to triage the different sessions or those different connections happening on my containers. And because we are getting that telemetry out of the containers too, that same Elastic Security Detection Engine is continually churning in the background, right? So if I go to Manage Alerts, I should be able to see some Kubernetes specific rules, right? So again, our threat research team called Elastic Security Labs, who is focused solely on the latest and greatest threats and is continually building content for the detection engine, for machine learning, so that you don't have to, at least you don't have to on day one. We also have a number of out-of-the-box Kubernetes-oriented rules. And to be fair, a number of the Linux rules, number of the Linux rules would also be applicable to anything happening inside a container. So going back to the slides, what did we see here? Hammering that one platform to both observe and protect, in this case, your cloud workloads and runtime environments. We're seeing, baseline posture assessments for Kubernetes lease, KSPM in this case, CSPM coming shortly, against the CIS benchmarks. And we're also seeing that kernel level deep introspection for the telemetry coming out of those containers via technologies such as eBPF. So let's get ahead of our cloud risks. And with that, Mateo, I'll pass it back to you.
Thank you, Joe. Great job with the demos. Before we move to the Q&A part of the webinar, I would like to quickly recap what you all saw, making some analogy with ELK versus Elastic Security. And again, knowing that Elastic Security is just an evolution of ELK, specifically created for the security use case of the Elastic Stack. So we started with capture it all. So now we have data integrations that come out of the box. No need to write your own normalization rules anymore. And we made it very easy also to manage the life cycle of your data, including a frozen tier based on searchable snapshots that make it really economical to ingest all your data in a budget-friendly way when it comes to data retention. We then moved to the automation component. So now we have a new detection engine that is part of Elastic Security. No need to use Watcher, no need to write code anymore. And more than everything, you also have content now that comes with the platform. You don't need to staff a team of threat researchers to figure out what detection you should have. You can just leverage what Elastic Security Labs provides. We then moved to from the security analyst workflows, like the streamlined detection and response with Elastic Timeline. A lot easier to use than discover, and more importantly, it's faster. So expect higher productivity for your security analysts. You don't need to specify the data bucket you want to search. You don't need to specify the columns that you want to visualize or open up each document to understand what a log message is describing. And the last two items of the demo, stops attacks at the source and takes security to new heights, reflect brand new features that Elastic Security introduces, starting with endpoint security and EPP that allows to stop the bleeding before it starts at the endpoint. And the last part was around our cloud security. We're starting with Kubernetes. Cloud security posture management is coming for cloud native as well. And really, this allows all of our customers and users to get ahead of cloud risks. Let's move now to Q&A. Thank you.
All right, great presentation, Mateo and Joe. We do have a lot of great questions coming in for you from the audience. While we take those questions, I've just brought up a slide for everyone out here. This is the Elastic Security reading room. And as you can see, there's a number of QR codes on there, but I also want to point out, if you mouse over those shortened hyperlinks, each one of those are hyperlinks. So you can actually mouse over those. You can click on those, and that will open up a new web browser tab or window in your web browser, and you can try out each one of these excellent resources for yourself. There's the Elastic Security Solution. There's information on Elastic Security Labs and many more. And then before we jump into Q&A, I also want to point out in the Handouts tab, you'll find this slide. If you want to just download it in PDF form, you can click on each one of these links really at your leisure. So if you have a question, now's the time to get it in, because we're kicking off Q&A here with this first question that comes from Gary in the audience. He wants to know, does this require its own agents installed on endpoints, or can it ingest data from other EDR tools like Microsoft, which may already be installed? Mateo, you want to take that one?
Yes, I can take it. So Elastic Security provides Elastic Agent, and as Joe demonstrated, you can enable the Elastic Defend integration to turn that agent into a sensor for the endpoint protection and EDR use cases. That said, at Elastic, we believe in security to be open, like with everything else we do. So we integrate with any other platform. So we do have integration, for example, with Microsoft Defender and with other EDR solutions. The only difference is that with integrations with third-party solutions, we make it easy to ingest data. We have integrations that we provide out of the box, but you wouldn't have the full response capability built in as part of Elastic Security, right? You will not be able to, with a command to isolate a host in Microsoft Defender. You will have to kind of build that integration using a webhook. That's certainly possible too, by the way.
Okay, got it. That's good information. Thank you. I know those integrations are going to be important. Another good one here, they're wanting to know, I think this one's for Joe probably. They want to know, concerning some of the XDR functionality you mentioned, how does that compare to some of the other XDR products in the industry? Joe?
Certainly. Yes. Thank you. So how does it compare? So it is our endpoint. So we're talking about the Elastic agent that gets deployed, and then it has that Elastic Defend integration. And that Elastic Defend integration is that kernel level sensor that you would expect from a different endpoint product, such as maybe like a SentinelOne or a CrowdStrike or Carbon Black. So again, that is our endpoint posture. And that's how it compares. Now you can get into feature by feature, side by sides, feature efficacy. One thing I might say is, if you wanted to read up on, don't take my word for it. Check out some of the Gartner documents. Check out some of the AV comparative documents where we've scored really well against a number of those industry vendors out there. But yes, that is our EPP, our endpoint prevention, our EDR, endpoint detection and response product out there. And like Mateo said, happy to ingest the telemetry from other security products too. Our endpoint is there. Whether you choose to deploy that integration is up to you. You might already have an endpoint product, but again, it's there for you to use.
Excellent. Another question here, this one for you, Mateo. They say it's impressive to see that now Elastic includes the full SIEM and EDR and cloud security functionality. How are these additional features licensed? How's the licensing work on this?
That's a great question. So it's as we covered during the webinar, it's still the same solution. So it's not, and as always at Elastic, we never had a la carte licensing for different parts of the product. So you get all these capabilities, and a big part of the capabilities that you have seen today are actually part of a free tier. So we still have a free tier. We do have commercial features. Like machine learning, for example, searchable snapshots, they fall under the commercial tiers, the paid for tiers. But the basic functionality, for example, of SIEM, also the content that comes with the SIEM and endpoint protection on the endpoints, that's part of the free tier. So you get a lot of capabilities. If you just need a SIEM with basic endpoint protection functionality, you can get that for free. We are also retaining the openness of what we do. So as you all know, our roots are in the open source, and still all our code for all the features, including commercial features, are open, and you can view the source code. of those, and we do the same also for the content that we provide. And I think that's something particularly unique in the security domain. If you trust an organization and their product to reduce your risk, you should be able to see how they do it. So you can see all our detection rules, not only when it comes to the detection engine in the SIEM part, but also the protections that run on the endpoints in our GitHub repository. So all of that is in the open.
Very cool. I bet a lot of folks don't know out there that Elastic has a free tier, and you can leverage that as a SIEM. So that's cool to know. Excellent. Let's see, another good one here. This one for you, Joe. They want to know, they say, I love seeing some of the new functionality that Elastic's creating, but right now I have Elk running on a couple of extra servers in our data center. Is there a suggested architecture for scalable security deployments?
Great. Yeah, totally. So, of course, Elk, or Elastic Logstash Kibana, the Elasticsearch product, is free and open source, and that's how it was started. Since the beginning of time, it was an open source project, and a lot of people would literally just install it on like a piece of extra hardware they had and run it, just like you might have stood up right now. When it comes to implementing, a production solution, though, a production security solution in your environment, you would probably better architect that solution to have, scalable hardware. It's a horizontally scalable architecture that we're talking about here. But what I want to say is there are really three main architectures that are supported. We have our own Elastic Cloud, which is the easiest way to get up and running too, by the way. You can go to just elastic.co/cloud and sign up for a 14-day period and play with all this stuff immediately. But we have our own Elastic Cloud, which is cloud agnostic. So we're going to orchestrate the stand-up of the Elastic deployment on top of AWS or Azure or GCP, right? So it's the Elastic front end, and we're going to orchestrate all that back end. So that's kind of what we call an Elastic Cloud architecture. Zero downtime upgrades, automatically scales if your cluster needs to grow, maybe during peak season, things like that. You can still do your classic on-prem or self-managed installations where maybe you're using provided hardware specs or something like that, but you can stand up, one or more nodes with the Elastic solution and, run it out of your data center, or maybe just running it on your own cloud architecture or whatever it is. And then also you can do a hybrid between the two, between, say, cloud and on-prem solutions. So the key takeaway, though, is regardless of the architecture you pick, you're going to want it to be production ready, great SLAs, automatically scalable. But what I want to reiterate is that there's feature parity. So there's no difference between an Elastic Cloud deployment versus maybe that science project you have running in a data center. There is feature parity there, regardless of the architecture you choose. A lot of words. I hope that answers it, but thank you.
Yeah, excellent. Yeah, thank you for clearing that up. Very cool. A lot of scalability options there when it comes to the architecture. Here's a good, just kind of basic question, I think, from Satyam out there in the audience, who wants to know that what's the difference between a SIEM and XDR? Mateo?
Yeah, I can take that. So in the security domain, there is always a new acronym to kind of learn and kind of understand, and XDR seems to be one of the emerging ones. So SIEM, as you all know, is an industry that has been, it's a product really that has been present for quite a lot of years. And the idea is that if you want to visualize activity within your environments or the environments that you want to protect, it makes sense to centralize those logs to gain visibility centrally. XDR, in a way, is an evolution of the endpoint security or EDR domain, and SIEM kind of merging together. It's an acronym that I think some of the endpoint vendors started using, acknowledging the need to add some more contextual information to the data and the telemetry that you get from endpoints for the analysts to make a determination when they do investigations. So XDR is really like my view of XDR, because different people have different opinions on what XDR truly means, is this convergence of SIEM and endpoint security together. When you're looking at protecting all your assets, yes, a big part of the attack surface is made up of your endpoints, but that's not all, right? A lot of that is in the cloud, a lot of that is in SaaS, Kubernetes, your applications, network data, and so on. So many vendors are now offering these XDR solutions that are really, in most cases, outside Elastic, is just a SIEM and an EDR solution pieced together. Two products that likely they were never designed to work together. In the case of Elastic, we have a native XDR because, again, it's a single platform, single agent. It's still Kibana, single user interface. You don't have to use a different user interface or a different product if you want to use endpoint security. It's still part of the same solution.
Yeah, that's really good to know because I know, in the world of security, we kind of get a product overload and we just have so many different products. Then the, efficiency goes down and the cost goes up. So it's great that Elastic can provide so many different solutions here all in one. Well, excellent. I think this is a great place to wrap up. Mateo, I do want to ask you one final question before we go, and that is just if folks are interested in this solution that we saw here, live demo, really cool. We saw it in action. How should they get started?
So the easiest way to get started, first of all, I hope that the main takeaway today is that Elastic Security is ELK, right? So we're not talking about the different products. It's an evolution of what you already know if you used ELK in the past. If you download from our website, latest release of Elastic and Kibana, you will see Elastic Security in there. The easiest way to get started, like with any software these days, is of course the cloud. We have Elastic Cloud, our SaaS, where you can spin up a free trial, or you can just download the software. As Joe mentioned earlier, you can, we support all deployment models, whatever makes sense for you today. So if you want to deploy on-prem, you can download the software and install it yourself. You can also install it on your laptop. If you're using Kubernetes, you want to run all your production workloads on Kubernetes, you can also run Elastic on Kubernetes, and we have an operator for that. And then finally, we have our SaaS Elastic Cloud. We support the three major cloud providers, AWS, GCP, and Azure, where you can stand up your deployments. We have a lot of resources. You can see some of the links here on our website, on the slide that you see with the QR codes. They all point to different resources in our website. You can find a lot of content there, going from webinars like these to blog posts to documentations that will guide you through the process. We also have fun workshops that can be used to get started. Like we have a Capture the Flag, for example, that you can sign up for, that will put you in the shoes of an analyst, really using Elastic to do real life type of investigation. So that's a quick way and easy way to kind of become familiar with the product.
Excellent. Yeah, so many next steps there, so many great options for anyone who wants to learn more and perhaps try this solution out for themselves. Joe and Mateo, it's been great having you on the event today. Thank you for the great presentation and the really cool demo.
Thank you.
All right. And before we wrap up, I do want to remind everyone about the QR codes on the screen and also the hyperlinks. You can just click on any one of those and it will open up a new web browser tab or window. And by the way, this same slide is available for download in PDF format there in the handouts tab. So make sure you download that before you go. And with that, it's my pleasure to end the webinar here by announcing the winner of our Amazon $300 gift card. This is going out to Steve Custer from Washington. Congratulations, Steve Custer from Washington. We'll reach out to you. And a final big thank you to our friends over at Elastic for supporting us on the webinar today. I encourage you to visit their website and learn more. I hope that you enjoyed the demos today, and I hope that you learned a lot. Stay safe, have a great day, and we'll see you on our next webinar. Bye-bye.